All right, guys. So section 8.5, we'll probably try to get one example done, then finish the next one on Monday. And I think that's all we do, and give you guys homework for it. You could probably work on it in class. Um, but partial fractions is when you have a denominator that can be factored, okay? And what we do is we separate it and try to figure out like how can we do this problem? What's another way for us to do this problem using not fractions, but using factors? So I'll give you an example of what I mean by that. So example number one, I'm going to want to write the partial fraction decomposition. Now what that means is write the decomposition. Write the way it's supposed to look like before you actually integrate it. Okay? So normally you would be given like an integral of the following. It's gonna be a fraction here. So normally there'd be an integral around this thing. And they tell you to integrate, right? So we're just going to take out the function and say, okay, let's break this down. Okay, so that's called the partial fraction decomposition. Now, we know that x squared minus 5x plus 6 can be factored into x minus 3 times x minus 2. Okay, so what I'm going to do is I'm going to basically say, all right, 1 over x squared minus 5x plus 6 is the same as 1 over x minus 3 times x minus 2. Right? That's the same thing. So what I'm going to want to do is break it apart. X minus 3 will be here, plus x minus 2 will be here. And it doesn't matter which order you do it. Sometimes your answers come out a little different, but they're still equivalent. So which one you put first really depends on what you want. And what I'm going to do on top is just put an A and a B. I got to figure out what numbers have to be in the denominators so that the right side is equal to the left side. Okay? So that's what I got to figure out. Like, what numbers should I pick? All right? So let me rewrite this one more time. That way we can do the multiplication part. But I'm only going to write the factored form. I'm not going to write the original equation. Okay? And you know what? What I'm going to do is actually, let me move this over here to kind of keep it a little bit more in line with the work that we're doing. So I'm just going to write that again. Not that you have to do it, but I'm just trying to keep it clean so when you guys look at the notes, you can see what happened. What I'm going to do is I'm going to multiply everything by a common denominator, right? So their common denominator would be x minus 2 times x minus 3. Okay, so I'm going to multiply left side by x minus 3 times x minus 2, and also all the right side. So what we end up with is a 1 equal to a times x minus 2 plus b times x minus 3, because things are going to cancel out, right? So we end up with that. Now this is what we want, because at that point I get to start saying, okay, what if x is this? What is a or what is b, right? So I'm going to look at my a term. I see a times x minus 2. So I'm going to try to zero it out. So I'm going to let x equal to 2. Because if I let x equal to 2, then I get a times 2 minus 2. Notice that's going to become a 0. Plus b times 2 minus 3. So 1 is equal to negative b. Or b is negative 1. So I just figured out what the value of b is when I zero out one of the numbers. Let's zero out the other one. What should I let x be for the other one? a 3, right? So that's 1 equal to A times 3 minus 2 plus B times 3 minus 3. So that becomes 1 is equal to A, so nothing else to do there. A is 1. Okay? So A is 1 and B is negative 1. That means that my partial fraction decomposition, that A over x minus 3 plus B over x minus 2, I can rewrite it like this. 1, well here, let me write it out properly. What was it? Minus 5x plus 6? Minus 5x plus 6 is equal to 1 over x minus 3 minus 1 over x minus 2. And this is my partial fraction decomposition. Okay? Now what if I asked you to integrate this? Okay, we got 14 minutes, so let's do that. Example number 2, let's integrate 1 over x squared minus 5x plus 6 dx. What you would normally have to do is do a partial fraction decomposition to break this down. Okay, but we just saw that the integral of 1 over x squared minus 5x plus 6 dx is equal to the integral of 1 over x minus 3 minus 1 over x minus 2 dx. Now you guys know that becomes natural logs, right? Anytime you have like 1 over x or even 1 over x plus 2, 1 over x minus 3, these become natural logs by use substitution. Let me show you the answer and then I'll show you how it gets done, okay? So the integral of 1 over x minus 3 is ln of the absolute value of x minus 3 minus ln of the absolute value of x minus 2 plus c. And we do know properties for the natural log. Whenever you subtract, they're actually division, right? So this is going to be ln of the absolute value of x minus 3 over x minus 2. And there you go. There is your integral for that problem. So notice the only thing I skipped in example 2 was rewriting my original function into a partial fraction decomposition because I had just done that. So to do example 2, you really had to do everything that's here. Okay, you would have had to have done all of that. Because first you'd start off with your original problem, then you say, okay, let me break it down. So you do part 1, example 1, break it all the way down, write your decomposition, and then replace it into your original problem. Okay, into that piece right there. From there, it's just integration. Now, if you don't remember how to integrate things to become natural logs like this, let me just show you one of them. You're going to let u equal to x minus 3, so du is just dx. So this will be the integral of 1 over u du, which is ln of absolute value of u plus c, which is ln of the absolute value of x minus 3 plus c. And the same thing occurs with the 1 over x minus 2. It's just literally just change the 3 to a 2 and you'll get the same integration. Okay, there's no difference. The only time there's like a difference is when like there's something in front of the x. So if it was like a 2x minus 2 or something, well then you'd end up with a half in the front or something like that. But in our case, there's no number in front other than a 1, so we're good. We can just do that. So that's how I would have integrated this piece. Whoops, I went to the wrong place. That one right there. And the same exact step to do the other one. Okay? That bothers me that it didn't look right. Are you guys okay with that? All right, so we'll stop right now because we do have a little bit less than 10 minutes. Tomorrow, not tomorrow, but Monday, we'll just do the last example. I'll give you guys homework on that. make sure you guys are finishing up your assignments, and do that total registration thing. You got 10 minutes almost, so you can do that right now.